So, Ni Min Hao Ma, that's about the extent of my Chinese, so thank you for putting up with it. I'm going to give a little talk on Hedera Hashgraph. And some of you may have heard of it, some of you may not, but it's a revolutionary technology that I think anyone interested in blockchain should know about. So first, what is it? It's a consensus algorithm. And so what that means is we are at the very bottom layer of blockchain. So all the applications you hear about, all the things that people are building, they have to be built on something. Some of them are built right now on Ethereum, some are built on Stellar, some are built on a variety of others. We are the base layer on top of which everything else can be built. What's unique about us is we are very fast, we are very secure, and we have something called fair ordering. And I think the first question you would ask is, where do we stand? And so where does this project stand? Lots of things in the blockchain space are ideas, and there are a lot of great ideas, but this is real. We have public speed tests, which we released. We launched the network just 2 weeks ago, and we're releasing our APIs for people to start building on us this month. So it's a very real, existing network suitable for all kinds of applications. So the next question is, who's behind it? Dr. Lehman Baird and Mance Harmon are the two co-founders. Mance Harmon led the Missile Defense Agency War Game Simulator. If any of you here have seen the movie War Games, maybe, maybe not, Mance actually led that department. And he has 2 degrees in computer science, and he is the non-technical founder. The technical founder is Dr. Lehman Baird, who has the fastest PhD in computer science in the history of Carnegie Mellon. He has 100 published papers in math. They both met in the Air Force and have been working together for 25 years. So this is not, some very recent graduates. This is a very experienced co-founding team. The rest of the senior team all have significant technology experience. Every one of them has worked in technology for a minimum of 20 years, with one exception. So everyone here has done this before, not in blockchain, but in software and in technology. So let's talk about the technology. What people don't like to talk about with blockchain is that blockchain is designed to be slow. If blockchain isn't slow, it doesn't work. The algorithm for Bitcoin, as I'm sure many of you know, is constantly calibrating how long it takes for a block to be mined. And if it takes faster, if enough resources are added, so a block can be produced in less than 10 minutes, the complexity of the puzzle to be solved is increased to delay the block production to make it take longer. And that's so the whole network can come to consensus. So people say, gee, blockchain is great technology, but we want it to be fast. Well, it's designed to be slow. That's how it works. So what Lehman has come up with is a brand new architecture designed from the very beginning to be fast and secure. And so it is not actually blockchain. It is a distributed ledger. It is a directed acyclic graph. So it's not a blockchain, but it has all of the attributes of blockchain while being far faster, far more secure, and fairness. And I'm going to have some fun slides on speed later. But the other element here is, how long has this been in progress? Some people have heard about this pretty recently. I'm guessing most people in this room have heard about it for about a year, 6 months. Maybe today this is the first day for some. But Lehman has been working on this since 2012. It took him 3 years to architect this solution. And then another year later, he published the white paper in 2016. We won our first enterprise client in 2017. And in March of this year, we announced the public ledger. And a key piece of this is that we needed to have an enterprise client in order for this technology to work. The goal has always been a public ledger, but in order for it to work, we need to have the support of a wide group of blue chip Fortune 100 institutions. We had to show it worked. That's why we have an enterprise client first, going back to 2017. But the real point here is it is a overnight success that took only 6 years. And so people say you came out of nowhere, but it was really being developed very quietly for a very long time. So let's talk about the public ledger and put this in context of other blockchain systems that everyone hears about. And I think in this space, there's a lot of competing companies and a lot of competing ideas, but we have put up an architecture here to kind of show the different categories, which I think is important because that then shows what the attributes are. So leader-based systems are first. A leader-based system is technically not blockchain. What leader-based system is all the events go to a leader, the leader puts them in order, and then sends them down to all of the constituent computers. And once the events or transactions are spread around the computers, you have consensus, and that replicated database exists. This can be pretty fast. It works very well in private permission settings. But the problem is you've got a leader. And when you have a leader, that leader can be DDoSed, it can be hacked, it can be shut down, and it also can affect the order of transactions. So leader-based systems work very well when you know all of the members of your network. When you know them, you then can ensure that they are not hacked. But what could happen here, just to give an example, is if a member gets hacked, it can start doing a DDoS attack to the leader. The leader would then shift, but then guess what? When the leader shifts, the leader has to give the new leader sends the IP address out to all the members of the network, and the attack resumes. So this only works for private permission settings. But there are a variety, and most of those examples down there are private permission settings. Some of them are a little bit gray, whether it's IOTA or EOS, which are a little gray in terms of leader-based or not. But if there's a leader, it's not secure. And that's all you need to know. And there are a lot of systems out there. The faster they are, the more likely there is a leader. So what's more secure than having a leader? Proof of work. This is what Bitcoin is. Obviously, it's what Ethereum is. The real attribute here is you don't know who's going to generate the transaction because everyone's racing to complete this puzzle. So you don't know how to shut it down. So it's very secure. You can't shut it down. But the problem is it's slow. And it takes enormous amounts of power, enormous amounts of electricity. And while the security works, you can't run real scalable applications on it. 5 transactions a second, 20 transactions a second just isn't sufficient for the type of global applications that I think we all could see happening and deployed with this technology. So the next generation is an economy-based system. This is what I think Ethereum is working on, Casper. And the issue with an economy-based system is it can be very fast. And the way the economy systems work is they assume every node of the network operates rationally to maximize their payout. So the concept is, if I am a good actor, I will maximize my payout by behaving rationally. And that is a fundamentally, it's a good architecture. It can be fast, but it asks the wrong question. Because the question isn't, if everyone's rational, what do they do? The question is, if someone is hacked, what happens if they don't behave rationally? And this system is so complex, it can't answer that question. And if you think about systems based in the real world on self-interest, you can think of the housing market. Very rational housing market, everyone behaves in their own self-interest, it still crashed. You can think of the stock market. Everyone behaves in their own self-interest, it still crashes. So just because people behave in their own self-interest doesn't mean it won't crash on its own without sending its events across the network. So it makes it very fast. But what we did here is we broke apart consensus and governance. And so this is a fundamental difference with most blockchains. So we have consensus, which is determined by thousands of nodes around the world, but governance is diversified among 39 blue chip companies. And what does governance mean? Governance means you set the pricing, you set the technical product roadmap, you actually govern the network. And for most blockchain businesses out there, consensus and governance are linked. And we thought it made more sense to break those two apart and have consensus be as broad as possible and governance also be diversified. And so we'll talk about kind of what a good ledger, what a proper scalable ledger needs. So what do you need for a really successful base layer? You need to be fast, you need to be secure, you need good governance, and you need stability. I'd argue right now, no one company has any of those. None of the technologies out there satisfies all four of those requirements until we came along. So performance, we're fast. And think about it this way. If you're going to have a network that's going to have thousands of applications on it, you need to have the scale and the transactions to be able to handle that, or it shuts down. Maybe you've heard of CryptoKitties. It was a popular game on Ethereum. It's just a game. And it basically clogged up and shut down the Ethereum network. You can't run a business that way. You can't tell corporations to build a project on you if a game can shut down your network and can cause service interruptions. That doesn't make any sense. Who's going to build on that? So you need to be fast, and we're fast. Secure. You have to be very secure. Trillions of dollars of transactions, we think, will be flowing across these networks over time. There is no tolerance for anything but the highest level of security. These will be targeted and attacked at every layer up and down the stack, from the application layer, consensus layer, everywhere. So we have asynchronous Byzantine fault tolerance security. What that means is every node comes to consensus on its own. You can take out up to a third of the nodes of the network, and it doesn't impact the speed or the consensus at all. It's very secure. And by the way, you can hack as well, and that also doesn't impact it. Governance. People think of governance, and it's a very sensitive topic in this space, and most of the projects are governed by foundations. And a foundation sounds good, and it sounds like it's a very altruistic approach, and it certainly can be. But just because it's governed by a foundation doesn't mean that it's not centralized, and it doesn't mean that there's more than a couple of people actually calling the shots. Just saying you have a foundation doesn't actually tell you how decisions are made or who's making them. And you can look at some very big protocols out there run by foundations, and we really know that one or two people are really calling the shots. You also can look at other projects where you have minor consolidation, and blockchain actually encourages minor consolidation. That leads to concentration, also not good. For us, we have a council of blue chip companies that will govern our network. And these companies, importantly, are from every region of the world, as many as 18 sectors, but more importantly, they only have a 3-year term. So a third of them are turning over every year, and we think that provides diversity by geography, by sector, and by time. And that's unlike any other governance model out there. We want this to be a enterprise-grade network, and so we think it should be governed by enterprises. And they will set the highest standards for speed and security. Stability. We are patented, and so patents are a bit controversial right now, but we think that the patents will actually prevent people from forking the technology. Anyone can read the code, you just can't actually have a copy of it that's authorized. And we think that will inspire people to actually invest capital to build on it. I'm running out of time, so I'm going to skip ahead to just something I think is interesting in terms of speed. So this makes it quite graphic. Bitcoin, about 10 transactions a second. Ethereum, 25. The quote-unquote next generation at about 7,000. And by the way, look at the cost per transaction there, and those numbers vary. Where are we? 100,000. And we actually go faster depending on the geographies we use, the number of nodes we use. So look at the cost, too. A cryptocurrency transaction for us is about 100 bytes. We actually allow micropayments to work for the first time. A transaction on us could cost 1,000th of a penny or less. That opens up a whole new world of transactions. And to put these speeds in terms that you can understand, that's about right. Snail to 2 snails to a donkey to a plane. We are the plane. And when people say the best technology doesn't win, I don't think many people here took a horse. I think people took a plane. And I think that is what the power of what this technology is. You know, people would talk about why isn't it used? I don't see it used so much. Look at the iOS store when it started in 2008. 3,000 applications. Anyone know how many applications on iOS and Android now? Any ideas? Well, I'll skip to the punchline, but the point is 3.5 million over that period of time. And so maybe this is the right analogy for blockchain, maybe not. Instead, let's look at websites. Isn't it crazy to think that back in '92 there were 10 websites? Do you know how many websites there are now in the internet? Anyone have an idea? Give me a guess. Billion, close. Just off by half. 1.8 billion. Now, the top 20 launched 11 years after the internet on average. Each one of those red dots is one of the top 20 websites. That's June of 2002. What's special about that year? Nothing in particular. But what happened a little before that? Broadband. And broadband, after broadband, most of those sites were created. And the few sites that started before, think of eBay, think of Amazon, they were able to take advantage of broadband. We think that we are the broadband of distributed ledgers. And so we think that once you see this low-cost, high-throughput technology actually deployed, you have a real chance for applications that people actually use to be deployed. So with that, we are fast, fair, and secure. Thank you. Question? Yep, NBFT. So the question is, what's ABFT versus BFT? And the ABFT effectively means that each node comes to consensus independently. And I skipped through that part of the technology very fast. We were running out of time. But it basically means that they all the nodes run the same consensus algorithm. They all vote independently. And the asynchronous means that they each come to consensus completely independently of each other.
So what would happen then when a node in a set of nodes creates a different output than the other node?
You need 2/3 to come. So the way this gets into the tech in more detail, but effectively transactions entered into the network. When it's gossiped around, and this combines a gossip protocol with virtual voting. So the event is gossiped around. Two pieces of information are added to this, which allow the network to see every transaction which has happened. And once you can see that, each node has a history of all the transactions in the network, and they can tell when it was actually added. So here we go. So right there, that event is gossiped around randomly. And what ends up happening is every node can see the whole history of transactions. So you can see A, B, C, and D each have a picture of the network individually. So A votes for B, C, and D. D votes for A, B, and C. So D knows what A, B, and C knows. And D can't add something that isn't there. And if it does, it takes 2/3 to come to consensus. So 2/3 basically agree on the state. And when that happens, it's added to the graph. Any other questions? I sprinted through the technology piece of this, but effectively what it does, because I didn't think we had time for it, but effectively what it does is it combines a gossip protocol with virtual voting. An event comes in, it's randomly gossiped out incredibly quickly. Each node is syncing with all the other nodes very quickly, maybe 10 times simultaneously, multiple times a second. And that looks like it doesn't look random, but it is random. And then with each event, a timestamp is added and 2 hashes. And those hashes allow each of the nodes to see the history of transactions. So all this gossiping gives each node the ability to know all these histories of transactions. And because they know the history, they each know when the other nodes know about the events. And so A can tell when B, C, and D know of an event, and D can tell when A, B, and C know of an event. And because they're all running the same voting algorithm, they all come to consensus at the same time because they all can see and know what everyone else knows. And that's what makes it very fast, because you're only sharing the minimum amount of information, and very secure because they each vote independently, which means if you shut one down, you shut 5 down, it doesn't matter. The others each arrive at the same answer.
Since nobody else is asking questions, so I have another question. So about micropayments, you say you use your consensus algorithm to enable micropayments. Can you elaborate a bit more?
Yeah, I mean,
give me an example of who's using it right now.
Well, I mean, the main point is that current payment infrastructure doesn't allow for micropayments. If you use credit cards, if you use any type of existing payment infrastructure, there's multiple pennies required for every transaction. You can't pay somebody a penny. And so because our consensus algorithm takes so little data, it's about 100 bytes per transaction, it's incredibly fast. So you could actually effectively on us send someone 1/100th of a penny, maybe even 1,000th of a penny. The previous panel mentioned Internet of Things and IoT communications. So we think that you will see IoT micropayments be big, cars communicating with traffic lights and gas stations and light bulbs ordering themselves, and refrigerators paying for electricity at certain times. That is where we see micropayments being very effective. We have just launched this network, so we don't have people deployed on it yet employing this, but we think this is the first big use application that we'll see. But similar to the internet, it takes, I think, years for people to really determine the best ways to deploy it.
Yeah, later in the afternoon, I'll talk a little bit about micropayments. We are using toying a bit with micropayments in the entertainment industry. So maybe later on we can chat a bit to see.
Certainly.
Yeah, thanks.
Definitely. Yes.
And is your technology open source or not?
The answer is yes, asterisk, or no, asterisk. And so the answer is it is open review. So we will be able to open it up and post it on GitHub so everyone can see it, but you're not allowed to fork it. So it's open review, but not technically fully open source.
So it's a private technology.
It's a private patented technology, yes.
Okay, so that's the difference between other funds. They have more people can be open source out, they can. So that's the difference between the
It's a big difference. And we think that open source actually, when you combine with crypto economics, leads to massive instability, with the incentive to forking driven largely by economics as much as by improving the code.
Yeah. So from application development point of view, you are limited to the world you're willing to entertain.
Sorry, say that again.
They had to subscribe to your
Yes.
Right.
And what we would say is there's plenty of projects out there that are fully open source, and we want to be an alternative for enterprises that don't need open source and who appreciate the stability. For example, if you spend $3 million building on a platform and it forks the next day, you then have to decide which of those two you're going to support. That we think enterprises do not have patience for.
I understand that, okay.
I have a question that since you research your company talking about the government, I'm curious, if you go to China, do you think you will suggest the China government to use your company's software or the idea or any suggestion?
I mean, we'd be open to having the government use it for sure. We haven't had those direct conversations yet, but we're open to it, certainly.
Okay. Hello, Tom. Now, firstly, welcome to our today's event. And I just heard your speech is very excellent. So about today's event, how do you think this event, and do you think you already got what you want?
Listen, it's great to be here. Ni hao, and thank you for having me. It's great to have this exposure to this group of investors and market participants. It's not something I've done before, And so I was interested to come to see your community and the people that you know, which is very different than the people we've spoken to in the past. And so I think it's important that we share the Hedera Hashgraph story as broadly as we can. And part of that is to the communities that you know well. And so very excited to do that and happy to be here.
How do you comment the big environment between China and U.S. blockchain industry? And do you want to share anything that what's your already learned or what's your plan about your own company?
We're global from day one. And so we have offices in Asia right now. We've a lot of people in Europe as well. But the first international office we had was actually in Asia. And so that's very important to us. China is a little harder for us to understand given some of the regulatory, hurdles there. But we know the technology is very applicable to all of China. And so we think it's inevitable that we have a bigger presence there. It's just a question of when and how and what the best way to do that is.
So about today, about your speech, what do you want to bring to the people about your industry?
I think what I want people to know is that we are going to be the most diversified consensus and also the most distributed governance of any of the public ledgers out there. And I think that when you combine that with our speed and our fairness and our security, makes us a really interesting project. And I think that is not as widely understood as how diversified our consensus is and how diversified our governance is. And that's something we're out there building. I also want people to know that we've minted the tokens. We've actually launched the network 2 weeks ago. So we are in real progress, and it's not just an idea or a white paper.
Another very interesting question. If you can describe blockchain for people that he or she never heard about it, how you will tell them?
So here's how I describe it. If I gave you $1 right now and we were just in a room together, you could say, no, Tommy never gave me $1. But if I give you $1 right here, everybody sees it and everybody knows I gave you $1. You can no longer say I didn't give you that $1. That's what blockchain is. It makes me, when I give you that $1, visible to everybody. Now, they may not know your name, they may not know my name, but they know that happened. That's really what blockchain does. Because without blockchain, I can't give you that $1. Instead, I go to a bank, and the bank gives it to you, and the bank is that intermediary. But right now, with blockchain, everyone sees it, and that allows it to actually happen without needing a bank in the middle.
Anything else you want to add about your interview?
Nope, thanks for having me, and I look forward to being back.
Thank you very much, Tom. Thank you. Welcome.
如果上面2大不能全部写报告，你一定要区块链平台，就是你这样子 run 个3-5个月就上去，对，总共一开始 run 个3-5个月就上去，run 个3-5个月就。